Hi everyone, we're looking at how to solve a quadratic equation by completing the square. So what we're going to do is actually draw a square, and we're going to show what the completing looks like so you can visually understand what that method is actually trying to say. So when we did binomial multiplication, say you want to do x plus 2 times x plus 3. What you can do for this is you can draw a little area model to help you keep track. So x plus 2 I could write like this, and this could be x plus 3, and then you just find every piece. This would be x times x, this would be x times 2, this would be 3 times x, and 3 times 2 would go here. And then we called that x squared plus 5x is total plus 6. So the area model is great for multiplying two binomials. It also works great for completing the square, because this is the thing we want to make into a square. Right now it's not a square because this is a different size than that. If it was a square, all the lengths of the square would be the same. That's our goal. So I'm going to draw that square over here, like this. And I'm going to put the x squared in the same spot that it was before. Now this is a terrible drawing, but it's supposed to be a square. And the x squared should be, let's try and make that a little better. How about like that, a little bit better. Okay, so an x squared is always going to be x times x. And then the x's here, I could bring that up top here, and I could bring this x length over there, because if this length at the bottom is x, so is that. And if that's x, so is that. It just has to be based on lengths. So our x's are going to go in this box and in this box. And then our constant is going to go in the very last box. And that's how we're going to complete the square, by finding that constant. So if it's a square, the 10x's here have to go into these two boxes evenly. They have to be the same amount in each box. I can't do like 7x and 3x, because that would be x plus 7 and x plus 3, which would not be a square, it would be a rectangle, because there's different lengths there. So in order to do this evenly, where we've got the same number in each box, we have to cut this in half. So we're going to take our 10x's, cut them in half, and then put them in each box. So we're going to do 5x's here and 5x's there. That way we're going to have, this would be 5, because 5 times x is 5x, and this would be a positive 5, in order to get those areas of 5x in each box. So x plus 5 times x plus 5 is a square, since they're the same length and width. To complete the square, we're going to find what goes in the missing box to actually make this a square. That's why it's called completing the square. And what that would be is, we'll just bring this 5 up and this 5 over. And 5 times 5 is what completes the square, 25. So what that means is we need 25 in our equation somewhere to make this an actual square that we can factor. So what we're going to do is we're going to rewrite this as x squared plus 10x plus what we need, 25. I need 25, so put it in. Well, this is obviously not equal anymore. I can't just add 25 and ignore the minus 5 and then think it's the same thing. It's not. So to kind of take care of that plus 25, we can also subtract 25, because that's just 0. It doesn't change anything. And then we're going to copy everything else that was in the equation. There was still a minus 5 there and a 0. So all we've done so far is just add in this 25 and subtract it out. And you're probably wondering, why did we do that? I could just combine those and call this an x squared plus 10x minus 5 equals 0 and get back to where I started, equals 0. But that's not what we're going to do, because that's not very useful. We need a 25 there because that completed the square. So I draw little square brackets around it to show that these pieces inside are the pieces I had in the squares area. So those are the ones I need. I know how that factors. That factors into a length times width that we already have over here, x plus 5 times x plus 5. So I can factor this into being x plus 5 times x plus 5. And the minus 25 and the minus 5, I can just call minus 30. Okay, now x plus 5 times itself is x plus 5 squared. Minus 30 equals 0. We call this something important. This is actually called Vertex Form. When it's like a times x minus h squared plus k equals 0, we call that Vertex Form, because the vertex is going to be hk if that's in that form like that. So when it's in this form, we know the vertex would be negative 5, negative 30. That would be the vertex if we needed it. That's what it would be. It's not going to help us solve this equation, but it's true, so that's cool. Great. So now we're going to solve this using square roots. We're going to solve this by moving the 30 over first, so plus 30 to both sides. We get 30 equals x plus 5 squared. We want to get rid of that square by doing the square root. Just don't forget the plus or minus. So we get x plus 5 equals plus or minus the square root of 30. And then we're going to solve for x by doing minus 5. So we get x equals a negative 5 plus or minus the square root of 30. And that's actually all we're going to have here. That's going to be our answer. Negative 5 plus square root of 30 and negative 5 minus the square root of 30, because square root of 30 isn't going to simplify. So if we had, say, for example, square root of 72, that's a 22. 72, we could call that square root of 36 times 2, which would be the square root of 36 times the square root of 2, which would be 6 square root of 2. That's how we could simplify that radical down if it looked like this. It doesn't. We've got square root of 30, which if you think about that, there's no perfect squares that are a factor of 30, because our perfect squares are 1, 4, 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and none of those are any factors of 30. So this is not going to simplify, so that's actually our final, most simple answer we can get. So that's it for that one. Let's do one more just like that. So let's take our original equation here, and let's put it in the square format. So here's x squared, x times x. And we want to take negative 6x and split it in half. So negative 3x here, negative 3x there. So that would be a minus 3 and a minus 3 as the other side lengths. And you can think of it as x plus a negative 3. So then to complete this square, you just fill in this box. What would that be? Well, that's negative 3 times itself, which is 9. So we need a 9 in there in order to complete this square. So we do x squared minus 6x plus 9. You can't just add 9 though, that makes it not equal, so you have to take care of it by subtracting 9, and then keep the plus 2 equal to 0. These three parts here were the parts in the square. That's this whole thing put together. So I put square brackets around just to kind of show that. We know how that factors. That's x minus 3 times x minus 3. Combine our like terms here, we get minus 7 equals 0. This is x minus 3 squared minus 7 equals 0. Which means the vertex would be 3, negative 7, in case we needed that. And now let's just solve. Let's do plus 7 to both sides. 7 equals x minus 3 squared. We take care of the squared by doing a square root of both sides. Just don't forget the plus or minus. X minus 3 equals plus or minus the square root of 7. Add 3 to both sides, and we get our answer. X equals positive 3 plus or minus square root of 7. Again, this is not going to simplify because 7 is a prime number, so it's got no factors besides 1 in itself. So it's not going to break down in anything like the other square root of 72 did. So that's our answer. 3 plus or minus the square root of 7. Those are the two possible values of x that would make this equal to 0.